Okay, we have on the board here a property of definite integrals. We have the integral from 0 to 2a of f of x dx equals 0. We have the condition over on the right that this is true if f of 2a minus x is equal to minus f of x. And in order to show this, what I was actually going to do is going to look at something very similar, but I think this is going to be a more general property. If we have the integral from a to b of f of x dx, well, this is going to be 0 in the case where if we have f of b plus a minus x is equal to minus f of x. Let's look at this one and see why this is true. Now, there's another property I'm going to use that's going to be useful for this. Now, the other property that we can use is what we use for King's principle that's going to make this happen. You'll notice the similarity. This is kind of the substitution we do with King's principle. And what we're going to have is we have for the integral of b, the integral from a to b for f of x. This is actually going to be equal to the integral from a to b of f of this thing, f of b plus a minus x. So this property is actually my first step because we have these two are the same. So what I can do is take this and say it's equal to this, our f plus ba minus x. But then we have this condition to the right that f of b plus a minus x is equal to minus f of x. So I can just substitute that minus f of x here. I'm just going to label this integral that we started with as I. And so so now we've transformed it. Our bounds are still going from a to b, but now we have this as minus f of x dx. But notice this is just the minus. I can take this minus up front, and this is just minus of this original integral. This is actually the same thing as minus I. So we're saying actually that I is equal to minus I. Well, then I can just add an I on both sides, right? And then on the left side here, we're going to have 2i, but then these are going to cancel, and then we're going to have 0. But if 2i equals 0, that implies that I equals 0. But this is what we wanted to show right here. We'll just show that our integral I is equal to 0. I said initially that this second case that I created here, this is actually broader, and it actually proves this, because you'll notice, now you notice it's kind of unfortunate that I have an a, that my variable choice is kind of unfortunate, right? So we should just use something else. So like instead of an a, let's just use like a t right here. Well, if we're doing that, if we're equating to this, we're just saying we've set our b equal to 2t, we've set our a equal to 0. Well, then coming to this formula, if we do if we do f of b plus a, that's just going to be 2t minus x. Well, that's exactly the same thing we have right here. We just substituted t for a. So this is actually the same thing as this. We've just changed the variable, which doesn't matter. We changed it from an a to a t. So by doing the second way, we've actually shown the first way, but it's broader because we've set our lower bound to a, whereas in this other example, our lower bound has to be 0. So this second way is actually kind of more flexible. Now that's all well and good, but let's just do a quick example of this. I think I do the example here, or should I do it in a separate video? Yeah, but if I do it in a separate video, I need to, if I do it in a separate video, then I have to point everyone to this other video. Yes, let's just do it. Okay, for my example, let's see. I think what we can do is we can have an integral from 0 to pi, and we'll just integrate. How about cosine? So for this to be a relevant example, what I'm doing is I'm claiming that this is going to be 0, and then we also have to have our condition. Whether we set this as a plus b or we do it the first way as just 2a minus x, we're going to have our function. We're saying that f of pi minus x needs to be equal to minus f of x. And our function, of course, is cosine, so we're saying we want to show that cosine pi minus x is going to be equal to minus cosine x. Now this is actually the supplementary angle formula, so we could just do it that way, but I think what I'll do is I'll use the different angle formula just to show it more clearly. So breaking this up with different angle, we're going to have, this is going to be the same thing as using the identity on this. So we're going to have cosine x times cosine x, and then we're going to have plus sine of pi times sine of x. But sine of pi is 0, so this whole thing is just 0. So we're just left with this. But now cosine of pi is -1, so -1 times cosine x gives us our minus cosine x, so this condition is true here. So since this condition is true, and what we proved earlier, this integral must be 0. But now the nice thing with this integral, right, it's real easy. We could just integrate and do it the normal way, so let's just do that just to feel good about it. So if I integrate cosine of x, we get, I'm just doing my answer all the way down here just to be sloppy. So we're saying the integral of cosine x is going to be sine x, and we're integrating it from 0 to pi. But when we evaluate sine x at pi, that's 0. When we plug a 0 in here, that's also 0. And so we show that our answer for this is actually 0.